Hello and welcome everybody to today's webcast introduction to MQTT Sparkplug plug and play operability for IIoT. So first of all, I am happy to present you today's speakers. Dominik Obermeier, who is CTO and co-founder of HiveMQ, and Benson Howland, who is Vice President of Marketing and Strategy at Opto 22. So welcome, Dominik and Benson. And now I'm happy to hand over to Dominik.
Thank you, Verena. So also welcome from my side. As already presented, I am Dominik Obermeier. I am the co-founder and CTO here at HiveMQ. We are a company based in Germany. We are basically near the Munich airport. We have been founded in 2012. And what we do is we help companies move data to and from connected devices in an efficient, fast, and reliable manner. And by using basically MQTT technologies. We have more than 130 customers worldwide, from companies like Siemens to most connected cars here in Europe and in the US. We have a lot of brands here and are focusing on the automotive industry as well as the industrial IoT industry. So today's topic is about Sparkplug. Before we go into Sparkplug, what it is and why it's important, let's go a step back and think about, okay, of the current world, of the current state of operations technology and information technology. As of today, a key struggle a lot of companies are facing is still there are a lot of data silos. This means a lot of companies are struggling with proprietary software and or proprietary protocols, which are very hard to connect to each other. And you effectively get these data silos. But the reality is the information you have on your factory floor, you probably need them somehow in other systems. And as of today, probably also in the cloud. So a key challenge is how to move data and how to break up these data silos and basically connect everything, but while still being secure and as efficient as possible. So there have been a lot of, this is nothing new, of course. This is a key struggle that's been there forever. So there have been protocols, from Modbus to very recently OPC UA, which are used to connect things, especially inside a factory setting. A key problem though is that you need to connect basically all the things together. All these protocols are using these this poll and response mechanisms, which is really, really great for the internet, which is also used a lot here. But it comes with problems because if you want to connect all the things, what you end up with is what we call a spaghetti architecture. This means you have something that's very hard to maintain. You have a lot of interdependencies and it's very hard to untangle. So this is something a lot of our customers and a lot of companies we talk to experience, that they have a very tight coupling between their applications, their services, their devices, and their gateways. And so what people typically end up with is, you can see here in the middle, all the arrows, this is what we call a spaghetti architecture. You usually start with connecting, for example, a gateway to, say, a SCADA system or an MES system. And then you have a lot of devices and sensors, which you probably also are using gateways for communication. Then you have things like OPC UA, then you have Modbus and a lot of other protocols. And then you somehow want to connect all that data to some applications in a bidirectional way. So what you end up with is something very complex and very hard to maintain. And while this might work for a single factory, especially if you have a setting where you have multiple factories and then you also want to introduce cloud communication to push the data to the cloud and back, then things get really, really messy. and are very hard to maintain. This is very expensive to maintain. But this is our reality we see a lot of companies struggle with. And especially when we consider the OT, the operations technology, and the IT, the information technology gap, this is something people are having sometimes a very hard time with. So the problem here is it's really difficult to change workflows and processes. And also, it's sometimes very difficult to set up new systems or new facility, and also connect all the applications or all the producers of data and the consumers of data together. And what is especially difficult is if you want to analyze the data across the entire system. So if everything works, this is fine, but a key problem is what happens if things don't work. And the problem here is with this kind of spaghetti architecture. Similar, if you look at a nice plate of spaghetti, the more spaghetti you add, the more complex it gets, and the harder it gets to untangle everything and making sense of things. So what a lot of people actually want is a decoupled architecture. This means something where you have this kind of central data hub where you can connect all your IT applications, but as well also everything in your OT world. So for example, you want to connect your gateways, you want to connect PLCs directly, you want to connect your devices directly to this kind of data hub. And then profit from having the central data hub by plugging in, for example, MES systems, historian applications, analytics, or some custom applications, which are getting more and more common. And the thing here is, especially in the IT world, there is a huge trend, microservice and service-oriented architecture trend, where things really get more complicated because large monolithic applications actually get split up in smaller applications. And you somehow also need to move data around. And again, if you would do a direct coupling of things, yes, you would add even more spaghetti. And this makes things pretty messy. So this is why a lot of companies had a huge interest in a technology called MQTT. And MQTT is something for people not aware of the protocol. It's a communication protocol invented in 1999. And so it's pretty old actually, from today we have 2021. So it's in IT terms, it's pretty old. And it was invented in order to monitor, to sense and act on oil pipelines. So Phillips 66 worked together with IBM and Arkham Solutions, and they were asked to build a communication protocol to use their satellite link, which was able of doing TCP/IP, and to move data in a very efficient way and as fast as possible from the field to the servers in the data center. Fast forward 2021, MQTT is by far the most important and most popular communication protocol over the internet when it comes to connecting devices. So if you own a car which has some connected functionality, chances are you're already using MQTT. If you're using some popular apps on your Android phone or your iPhone, chances are you're using MQTT for moving data around. So MQTT is basically everywhere where the Internet of Things is happening. And now MQTT gets a comeback where it actually originated from, which is the connected factory, or let's say the SCADA systems, but also factories actually. But the question is, why is it so popular? On the one side, it's extremely simple. So for comparison, MQTT has a specification which has 100 pages, 100 pages worth of specification. If you're looking at OPC UA as contrast, it just as base specification is more than 1,000 pages. And if you want to have a complete OPC UA implementation, you're looking at multiple thousands of pages worth of specification. So people are looking for something simple because complexity is hard to master. And MQTT is so simple because it uses something called a publish-subscribe architecture, which I will talk about in a second. It is extensible because the great thing about MQTT is, and this is why it's used in so many industries, is it does not care about the actual payload, about the data that is sent over it, and how you structure your communication. For example, topics and so on, which are addresses you send and receive data to and from. MQTT is built for reliability. So if you need to make sure that data is processed and the data is actually sent, even if you have some disturbances in your say signal strength, or even if you have a connection drop, which happens as soon as you add in the internet in the communication path. So it has reliability built into. And it decouples clients and the so-called data broker. So how does this look like? So with MQTT, you introduce an MQTT broker, which in our case, HiveMQ, we happen to develop one of the enterprise MQTT brokers used in many industries, especially when scale and security is important. But you could, of course, use any MQTT broker here to demonstrate the MQTT principles. So you have so-called publishers, which are data producers, which send data to the broker. And then it's the broker's job to figure out where this data needs to be sent to. So in this case, we have two so-called subscribers, which have a subscription on specific data. And as soon as the broker receives a data point, it makes sure that everybody who is interested in gets the data. And the broker does not care if you have one device interested in this data or 1 million. And this is not an exaggeration. We actually have customers who send one data point to millions of devices. And this means we have a complete decoupling. And the great thing is MQTT uses a push architecture, which means as soon as a data point is received by the broker, you get the data point, usually in sub-millisecond latency, of course, depending on the network you're using it on. The problem, though, is, and this is where Sparkplug enters the game, there are still issues. Because devices and endpoints, if they need some kind of orchestration, you have different data points. The one device could send, let's say, JSON data. The other could send a binary data. The other could send XML data. So you have a plethora of different options here, and MQTT doesn't care. But the thing is, if you want to achieve interoperability, you need to care about what kind of data your applications send and receive, and also your devices send and receive. Also, another issue is that, as I pointed out, the applications assume specific data formats. So if somebody wants to have, let's say, JSON or protocol buffers, then you cannot send an XML file. So you really need to make sure that, although you're decoupled, that the applications can speak the same language. This is, and again, this is where Sparkplug comes into play. What is Sparkplug? Sparkplug is a simple open specification that will enable plug-and-play interoperability between IIoT devices and IIoT applications. And it does so by adding a defined topic namespace, a data model and a data structure, an extensible process variable payload, and it defines the MQTT state management. What this means, I will explain in a second. And I think if you want to have an analogy, if you look at the web, you have HTTP, which is used for transporting data. If you want to have a web page, for example, you have HTTP, but then you have HTML, which gives semantics into HTTP. The same is for Sparkplug. So you have MQTT, and on top you have Sparkplug. So you could say what HTML is to HTTP is Sparkplug is to MQTT. So there are some key concepts in Sparkplug, which I think are important to understand. And this is continuous session awareness on the one side, report by exception, interoperability by consistent data format, and auto discovery. So continuous session awareness is something, I'll make this shortly. This means that basically everybody in the Sparkplug communication knows the exact state of all the other applications and devices. This means if a device is offline, everybody knows. And at least, and this is important, at least the SCADA system knows. And what is so awesome about Sparkplug is it does not use a poll principle. So MQTT, as I said, is push-based. And this means while, let's say, you want to have an update of your PLC and you wanna read some values. What you would do is, let's say you would go to your PLC and go there every 5 seconds and ask, hey, did something change? And then you get a new value. But it could happen that the value doesn't change at all for a very long time. So you're basically wasting bandwidth and compute power because you're doing something that is not required to do. So what Sparkplug adds here is it utilizes MQTT by report by exception. So every device, every application just updates the value, pushes the data to the broker. The broker makes sure that everybody who is interested in the data gets the data point. So if you think about this, this is a paradigm shift because now you only send data if you need to, and you don't need to poll all the time and waste compute power and bandwidth. And then even if you poll every 5 seconds, there's still a, let's say, 4.99 second window where you miss an actual update. And with Sparkplug and MQTT, you get an instant update as soon as something changes. And so you get this massively scalable architectures where with Sparkplug, you can connect all your factories around the globe and have actual millisecond style communication around the globe. And the only limit is the underlying network. So this is cool. And again, you have the interoperability by a data format. And as additional goodie, you also get auto discovery for free, which means you can discover who is sending what data and who is in the network. So how does a Sparkplug architecture look like? A Sparkplug architecture, in this case, looks like you have 5 categories of different things. You have MQTT. Let's start on the left. We have devices and sensors. This could be like a classic sensor. This could be, actually it could be a PLC. You probably have OPC-UA as a communication protocol, Modbus. You have digital inputs and outputs or analogous inputs and outputs, and so on, which then you usually connect to a gateway. And the gateways are called in Sparkplug edge of network nodes. The edge of network nodes are a very important concept, which I will cover in a second. But also a PLC, which is Sparkplug enabled, can directly act as an edge of network node. Also devices, this could be literally anything that understands Sparkplug, can create Sparkplug messages or receive Sparkplug messages, can connect directly to the middle, to the MQTT broker, which then allows you to distribute data to wherever you need it. And then you usually have a SCADA system, a SCADA host, which is in Sparkplug language an IIoT host, which is responsible for making actually sense and of the whole deployment, and basically is one of the main components because you usually are in a SCADA context. And then if you're going to the right, we have the MQTT application nodes, which are the applications on the IT side, which usually consume a lot of data, but you can also issue commands back to the OT side here by sending data to the MQTT broker, which will then send the data to the edge of network nodes and then do something meaningful with that. But I will go into detail here what this is. So the SCADA IIoT host is the application responsible for monitoring and controlling all the MQTT edge of network nodes. It maintains a continuous session state, and does so by maintaining, it understands what PLCs are online, when the last value was received and sent and so on. So you can really understand what is happening. This is very, very important. But it's not responsible, and this is key, it's not responsible for establishing or maintaining connections directly to the device. What we've seen here is that device, and this might be, the device is usually connected to an edge of network node or directly to the broker. So the devices itself make sure they are connected at the network, and if they lose the connection, the broker has a mechanism to tell the SCADA system that a device is offline, and you get this in an instant. So then we have the edge of network nodes, which I talked about briefly. This provides physical and logical gateway functions for devices that do not implement Sparkplug. And so what you can do is you basically can bridge also other protocols, also legacy, let's say hardware and software, and bring this to a Sparkplug system. So if you already have an OPC UA system and want to leverage Sparkplug in the future, you can just use an edge of network node by using a gateway, and then bridge and bring together the best of both worlds. What we see a lot is actually OPC UA is of course here to stay, it's used widely, but Sparkplug and OPC UA are used in conjunction. And really the best way to bridge the IT and OT gap is Sparkplug. And if the more you're on the OT side, then also OPC UA again is here to stay and is used a lot, obviously. Then we have devices and sensors. This is really something this could be anything, and this depends, of course, a lot on the use case and the actual hardware you have. But you need some devices and sensors to actually do something, of course. And the MQTT application nodes, these are really applications where you want to consume and produce data to. And this could be anything. And actually also the MQTT application nodes could reside directly inside the factory or in the cloud. So this really depends. You're 100% flexible with Sparkplug and MQTT. And this is one of the great things, because it does not dictate you how you want to use it. The further you go in a journey, the more appetite you will get for additional MQTT applications. And it's literally just connecting a new application to leverage all the data you already produce and send and do something meaningful with it. And a lot of MES systems, historian applications, analytics systems, and so on support MQTT and Sparkplug out of the box. And then last but not least, you have the MQTT broker, which is something, and this is just one thing what you need. In order to use Sparkplug, you need a 100% compliant MQTT 3.1.1 broker. So you need all the features like retained messages, last will and testament, quality of service, and so on. I won't go into detail here, but be aware, if you want to utilize the cloud, there are vendors like Microsoft and AWS who have their Azure IoT offering and the AWS IoT offering. You cannot use them with Sparkplug together. They just implement a proprietary subset of MQTT and not the open standard. And thus you cannot use Sparkplug, unfortunately. So you need a real MQTT broker. There are a lot of commercial and open source options available, but this is a key pitfall we've seen a lot. So ask your vendor if they support the whole standard. This is key. So in case of HiveMQ, we have a whole platform around MQTT from device libraries in order to bring in the data and the devices easily to MQTT. To an MQTT broker, we have a lot of additional features we want to have. For example, high availability. You don't want to be the central data broker to get offline. We are 100% MQTT compliant to all versions. We have customers who scale to millions of devices and hundreds of thousands of data points sent and received per second. Scalability, again, is key. Observability is something we provide. So if there is a problem, we help you detect where the problem is. Sometimes even before somebody recognizes that there is a problem. We integrate with all the enterprise security things, because we have a lot of Fortune 500 customers who really care about security and enterprise security. And we have an extension system which allows you to bring the MQTT data directly to enterprise systems, for example, IT systems like Kafka, Oracle databases, MongoDB, and so on. And you can run it everywhere. You can run it on a server on your factory floor. You can run it in the cloud. You can run it cloud natively. And we also have an option for HiveMQ Cloud, which means, which we will see now in the demo. So we teamed up with Opto 22 in order to present you a really neat demo. And I just want to walk you through now what you are going to see. So while HiveMQ is used a lot on premise, we also have a managed cloud offering, which allows you to have a dedicated account, which has enterprise security built in. And actually what you will see now in a second is that there is Groov Rio, which basically is in California, in the US. We have a HiveMQ cloud broker running here in Germany, so around the globe. And the Rio will produce data. And as we see in the demo, Benson will talk about this, what you can do, because you can actually interact with the demo. So it's a small spoiler alert. And with HiveMQ Cloud, we are leveraging the HiveMQ extension system, where we take the data, the Sparkplug data, and then forward it to InfluxDB, which is a time series database, and to Grafana, which is a dashboarding software. So actually, what you will see now is you will see actual hardware with the actual software, and you will get as real-time as it gets in soft real-time terms, from data from the US over to Germany to the time series database, which allows you to get, no matter where you're on Earth, a direct and instant data notification. What you could also do, which we haven't shown for brevity purposes, is you could, of course, also push the data to Confluent Cloud, for example, which is also, especially with enterprise customers, very popular, MongoDB or other databases. But in this case, we focus on a time series database to make it simple. And with having that said, I'd like to give the mic to Benson. Benson, the stage is yours.
Thank you, Dominic, and hello, everyone. Thank you for joining us today. My name is Benson Hoagland with Opto 22, and before I begin, a quick shout out to our friends at HiveMQ for inviting us to share what we're doing with MQTT and Sparkplug B, primarily from a hardware and I/O perspective. And also a shout out to my good friend Arlen Nipper from Cirrus Link Solutions. Arlen, of course, was the co-inventor of the MQTT protocol and the Sparkplug B specification. And the good news is they've moved all of that technology into the open source, so all of us could take advantage of this really important technology. So over the next 20 minutes or so, I'll begin with 5 minutes of slides about Opto 22 and our products, and then jump into a live demo with all the cool MQTT-enabled gear I've got around me. I'll also show you a live dashboard of sensor data from this studio and perhaps even to your smartphone. So be prepared for that. But first, for those of you that are new to Opto 22, we are a California-based, privately held manufacturer of industrial automation hardware and developers of the software that resides within our products. We have over 4 decades of experience with an installed base in the millions at thousands of customers all over the world, and we're known for highly reliable, mission-critical, USA-made products backed by lifetime warranties. But what makes this kind of unique in the marketplace is our engineering philosophy for combining IT technologies with OT systems into affordable and capable systems that can save you time, money, and effort. And here's a drone shot of our factory located in Temecula, California. We're about an hour north of San Diego. It's where we design, build, and support everything we make. This is also where I'm broadcasting live today from our Opto demo studio. So although we have over 10,000 customers worldwide, here's a small sample of some of those customers who have implemented MQTT solutions, and most of these are with Sparkplug B payloads. And many of these customers have turned to our elite team of IoT certified Opto partners to ensure a successful implementation in a broad range of industries, including things like process control, discrete manufacturing, water, wastewater, pharmaceutical, and so on. And each of these industries pursue various applications, from traditional control, monitoring, data acquisition, OEE, and much more. But of course, most of the recent focus has been on digital transformation projects, including IIoT and Industry 4.0. And the products I'm about to introduce support a wide variety of real-world signals, many different types, allowing you to connect to virtually any sensor, circuit, environment, or device, and move that data where it needs to be. Now, sometimes getting started is the most difficult step, so we're doing everything we can to make that as easy as possible as well. There are numerous ways to reach us and speak to an engineer directly about your application. We're here, we're willing and able to assist you in your MQTT application journey. Now, on to a very quick overview of our MQTT and Sparkplug enabled products. First is Groov Epic. This is a real-time edge programmable industrial controller. And second is our Groov Rio, what we call I/O for the IIoT, and so much more. Now, Groov Rio will be the focus of our upcoming live demo, so stay tuned for that. So in short, Groov Epic is a hardware platform that combines into a single backplane a real-time logic controller, or PLC, an operator interface, including the ability to connect to an external HDMI touchscreen monitor, a fully secure network gateway with user accounts, firewalls, certificates, and everything else, plus a world-class I/O subsystem built on legendary Opto 22 quality. And of course, this product has MQTT Sparkplug B enabled directly inside. So there you go. Now, the system architecture for the Epic looks something like this, where we're going to pull in analog, digital, and serial I/O, and perhaps even data from other PLCs or other devices directly into the Epic, and then use Sparkplug B and MQTT to move that data throughout the enterprise, or what we call move it into infrastructure. So I'm going to demonstrate how we're going to move this directly into HiveMQ Cloud. But again, that could be on-premise, it could be on devices, and so on. Now, next up is Groov Rio. Now, this is a compact standalone I/O system that's nearly infinitely configurable for just about any I/O signal that you might need. And because each channel is software configurable, there are over 200,000 unique field I/O combinations possible with this single device. And all of that I/O data will be accessible via MQTT and Sparkplug B. In fact, you can even use PoE, or Power over Ethernet, to power this Rio and most of its I/O. And setup is really simple. I'm going to demonstrate that in a moment. You simply navigate to the built-in secure web server, configure the I/O channels, then configure where your MQTT broker is, and almost like magic, all of your I/O data begins publishing up to your HiveMQ broker. Now, sometimes getting a sense of all the I/O possibilities on Rio is difficult. So we developed this matrix here to indicate which each of the software channels are on the device and which signal types are supported. Now, this matrix can be found on our website, and it's also in all of our documents. Okay, finally, the Rio architecture looks like this, somewhat similar to Epic. You connect to your various I/O channels at the bottom down here, configure your I/O and your data destination, publish data to infrastructure, whether on-prem, in the cloud, or on your devices, and then start consuming that data by applications, including the SCADA IoT host, as Dominic described, or as I'm going to show you, InfluxDB, and so on. Okay, we do get a lot of questions about how these compare. In brief, both Groov Epic and Rio have a lot of similarities relative to getting real-world data up to your HiveMQ broker. Now, Groov Epic is really ideal for high point counts, or if you need real-time control, or if you'd like an onboard operator interface or an HDMI interface. Now, Groov Rio is ideal for up to 10 points of I/O per module, but again, configurable in a myriad of ways. And of course, provides PoE power And again, if you have, if you want a single part number for a whole bunch of different applications, Rio is really a great way to go. Okay, terrific. We're past the death by PowerPoint portion of my presentation. On to the fun stuff here. We're going to switch gears and go over to my demo. And here we are. Let me pull up my browser for you. Okay, so here I am in the studio. I've got my cool little demo panel right here. You can see if you look down, you should be able to see my demo panel where I've got some sensors and stuff. I'll talk about that in a moment. And then right over here is my browser that is, I'll be logging into the Rio to actually get this thing started. So let's take a quick tour. I'm going to switch screens here so you can get a bigger view of what I'm working with. So let's start from the top. Up here on the top of my Rio, I have a little temperature sensor wired in. I'll show you that in a moment, but it's just a simple, low-cost, something called an ICTD, integrated circuit temperature device. We'll get back to that in a moment. I've got some other things wired up here. I've got a couple of wires here that go to my stack light, and this stack light will be able to turn on and off. Show you that in a moment. I've also got here, if you look in my side screen, you can see I've got a column of water here, and inside is a temperature or a level sensor. That level sensor is a 4 to 20 milliamp circuit, and it is too wired up here to my Rio. The other thing you'll notice is, let me just pop this guy off the DIN rail. As I said, Rio is a pretty compact little unit. You've got a lot of information on the label, including all the certifications, UL, CE, ATEX, Class 1, Div 2. This guy is ready to be put just about in any location. Okay, one other sensor I have here is this door sensor. And this is pretty simple. This is, these I don't know, like a quarter or maybe 50 cents on Amazon. It's just got two little parts here. As I move them together, I can put them on a door to know when the door opened or closed. Now what I'm going to do is actually wire this sensor up to the Rio and show you how that's done. Now to do that, you may be asking yourself, well, how do you wire it up? Where's the instructions for doing that? Well, here's the good news. We actually have that built in. So I'm going to switch back over here to this screen, log into my Rio. Let's go ahead and do that. And I come to the home page. As I said, Rio and Epic are both secure devices, have a secure web server on it. So I'm actually going to come in here and type in my username and password. And there we go. And securely log in with the account that was created when this system first started up. I'm going to jump right in here. There's a lot to cover, but we don't have the time to go over a full Rio demo. I'm simply going to go into the IO reference, and here I can see I have wiring diagrams. Now this little device I described is a dry contact, and in that case it needs to be powered. So I can come right down here to switch input powered, click on it, and look at that. My wiring diagrams for all my channels of I/O are built into the system. So there you can see channel 0 was actually the temperature sensor. So I'm going to use channel 1, and it says to use pins 4 and pins 5. Terrific. Let's switch back and show you how that's done. Okay, so I've got my handy tool here. I'm just going to come in here and push it into channel 4, take one of my leads here, and push it into number 4. Then I'll take my tool and I'll push it into number 5 there, take the other lead and pop it in right into number 5. There we go. Release my tool, give this guy a good little tug, and voila, just like that, I've wired up a door sensor to my Rio. So next, I want to see if it works electrically. The good news is we've got an LED array right on the top of the Rio here, so as I move my sensor closer, you can see that little LED turn on and off. So I've electrically connected it properly, provided power to the sensor, the whole 9 yards. Now let's take a look at the software side of this and see how it goes. Okay, so I'm going to switch back my screen. I'm going to go back all the way to, let's just go right to the home screen, and I'm going to go to I/O channels and show you how this thing was actually configured. So there we go. And there's my door sensor. Now I have pre-configured this I/O because we are moving the data up to the dashboard, which I'll show you in a moment. But I want to show you how I did it, and it's really pretty simple. So here we are on the door sensor page, channel 1. If I go to configure, the first thing essentially this is just filling out the blanks or choosing from a list to get this thing configured, and it's all web-based and all directly on the device. The first thing is the name, and the name is relatively important because in Sparkplug B and MQTT, that name becomes the single source of truth. So as I name this door sensor, that will be the name or the tag throughout the entire system for any applications that want to subscribe to this data, how I produce the data, all fits into the topic namespace as defined by Sparkplug B. So pretty cool there. Then the second thing, as I told you, this is a software configurable device, so I need to choose from the available list of sensor types for this channel. And as you can see, there's a lot of them in there, so you can get a sense of how you can get to 200,000 different configurations pretty quickly. In my case, I'm a switch input, power digital input, and I'm in good shape. Now on some of those inputs where we may be getting, like in this case, a door sensor, it could be maybe a proximity sensor to account how many products a machine makes, or it could be a sensor to tell if a machine is even on or off for like OEE applications. So for that reason, we have some features on there that allow us to configure that input to be even smarter. In this case, it's a counter, but it could be, how long the door was open or closed, or how many times it happened, which is what I'm doing here. Okay. Let's get the MQTT part. This public access it becomes very important because this is the data from that sensor I'll be publishing to the broker. So in this case, as you might imagine, I want to publish the state, and this will happen on change because that's how MQTT and Sparkplug B works. If it changes, it publishes a message to the broker to be consumed by other applications. But that's only the state. In this case, I could also send the counts, which I'm doing here. So anytime the count changes, it'll publish that data as well. So if you think about that, that's 2 data points coming from a simple door sensor right from the reel. The writable is also available so that I could actually write to that data point and say clear the counter after a given day or whatever. Okay, so there you go. I've got my sensor there. So from a software side, let's make sure it works. So I move this closer, the on comes on, I can actually test things out, everything's working, and you can also see there my counter keeps going up as well. So pretty straightforward on wiring up a piece of I/O and configuring it in software. Now there's a couple other things here I might as well show you. There's my temperature for my studio. If I put my hand on the temperature sensor here, let me move it over to the video so you can see, you'll start seeing that temperature increase as well. I can just click on it and I can see those values, including the min and the max values. So there you go. Let's come back to channels. Same thing with this, say the level sensor. So in this case, I've got this what's called a level rat tank level. So as I move this in and out of the column of water here, you can see that that value is changing in my screen. So that's pretty cool. Now, one last thing is I've also got this digital output, something to turn something on or off. And so if I click this toggle button, locally, I'm turning on and off this LED. So there you see, we're turning on and off the stack light. That's also all MQTT enabled. Okay, we've got all our sensors, we've got all our outputs, we've got our level sensor, all of it's ready to go. We've defined which data points we want from those sensors to be published to MQTT. The next step is simply, how do I configure MQTT? Well, that's not too difficult. Again, fill in the blanks. I'm going to go over here to the MQTT option. I can see that it is running. I'll go to configuration, and again, as I said, kind of fill in the blanks. So the first thing is, the beauty of Sparkplug B is it helps define the topic namespace, and that is essentially the topics that you're going to be publishing data onto. So in this screen here, I'm defining the first 2, actually all 3 of the topic namespace, including group ID, edge node ID, and the device ID. These are some of the things that Dominic talked about briefly in the first part of this webinar. So in this case, I'm publishing under the group ID Opto 22, edge node ID HiveMQ, and then my device ID is down here where I give it the device ID of HiveRio. You'll notice that later on in the demo with that particular term. The next part, so what I've done is create the namespace. Now I have to say, well, where am I going to send the data? So now what I want to do is figure out, which broker I want to use and get all the information from that broker, including its URL and of course its credentials. So I'm going to open a new tab here. And I'm going to come into HiveMQ Cloud. I've got a little shortcut here. Now I'm logging in to the HiveMQ Cloud that is in Germany that Dominic described earlier. The folks at HiveMQ have set me up with a cluster. So I'm going to go to my clusters. And indeed, I can see there's my starter kit. And I go to Manage Cluster. And here I have my URL for where the broker is and the port. And notice that port is a TLS port. So I'm going to make an encrypted connection up to the broker over port 8883. And that's the beauty of MQTT, is it leverages TLS security for MQTT traffic rather than it being built into MQTT. Now the second part is I have to have the credentials to log in. So I have to have the right username and password to actually, once I connect to the broker, I have to authenticate to it. And that of course is down here with my credentials. So now that I'm armed with that data, I can come in here and look at my broker configuration. And indeed, there is my SSL URL to hit the broker, my client ID name, which should be unique, and of course my username and password, and that I am going SSL. So here we go. We've got all the pieces in play. We're actually communicating to the broker. Next thing is, well, what does it look like? What can you do with this data? Well, as Dominic described, I'm going to open up a new tab. And what we're doing is we're taking all of this data from this device, we're pushing it up to the broker, and then at the other end, HiveMQ has the extension that will move that data into an influx database. But it's no fun looking at tables and rows. It's more fun to look at dashboards. So let's take a look at the Grafana dashboard that the folks at HiveMQ built from this data set. First thing you'll notice is all my demo studio temp, my tank level, these are all the tag names that I created when I put this system online. So the entire topic namespace path is right in there. And indeed, let's look, there's temperature. You can see right there when I put my hand on it, it raised the temperature. So we're trending that in the time series database. My tank level, you can see there that when I removed it and put it back in the last couple of times I've done this while we've been on this webinar, it of course is trending that. Now I'm also seeing here my door sensor. Now remember that my Grafana dashboard is refreshing every 5 seconds. However, anything that's happening here at the Rio is happening at sub-second levels. So as I move my door sensor forward, it may take up to 5 seconds for that to be shown on the dashboard. There you go. So now I have a record of every time the door opened and or closed. So that's pretty cool. But here's where it gets really cool. Dominic already talked about, we've got servers in Germany, we've got AWS servers where Grafana is being done, this dashboard, and you can see that right up here in the URL. It says EU Central. This is an EC2 instance running on AWS in the EU Central, which of course is Europe. So if you think about this, I've got a dashboard on my local computer here in Temecula. I'm going to click a button on this screen, which of course will send that information to the server that's running on AWS. And on that server, it's connected to the entire subsystem. So we'll actually send that data through the broker, and this Rio is subscribed to any changes on the topics that it's publishing on. So here's what's going to happen. I'm going to come down here. I'm going to click this Turn On LED. And that's exactly what's going to happen. I'm going to send a message that's going to go all the way back through that infrastructure, back down into this Rio, and turn on the stack light. Now, you can imagine if we're going halfway across the world and back and through various networks, because there's a ton of them in there, it's going to take a while. Let's take a look and see how long. I'm going to count it down. 3, 2, 1. How about that? And even with the latency and the Zoom call and everything, I'm literally turning this thing on through the entire MQTT architecture right down to this device in less than a second. In fact, in most cases, it happens before any of the dashboards or anything else actually show it. Here we go again. I'm going to show you one more time in case you missed it the first time. 3, 2, 1. Click. There you go. That's the thing about MQTT and Sparkplug B. The performance is astonishing. It's absolutely secure end-to-end, encrypted channels, authenticated and everything. And it's simple to do. I mean, when you start having products that have Sparkplug B built in, combined with the infrastructure that's in place, and then imagine all the software applications that can connect to that broker and consume this data, you can now get on the road and running quickly with your digital transformation or IIoT projects. Now, what fun is this if I'm the only one doing it? I've got a way for you to actually use, as I described earlier, for you to do this from your own phones. I'm going to throw up a QR code. Should be on your screens now. Snap that with your phone, and it will load up this dashboard, a public view of this dashboard on your phone. And as if you scroll down a little bit, you'll see those same buttons, so you can turn this LED on and off. So while you guys are looking at that, I'll point out one more thing. Thank you. Thank you for playing. I'm going to open up this one last thing I'm going to show you is some of the insight you can get into the HiveMQ broker running up on the cloud. So there's well over 100 of, actually several hundred of you on the call. So there's probably going to be a little chaotic messages coming in here, which is fine. It's like a blinking Christmas tree. All right, so quickly I want to go into the clusters, and I'm going to show you there's a button here for Control Center. I'm going to click on that. And again, this is kind of the insight into the actual broker itself. So I can get a dashboard showing how many clients are connected, how many transmissions are happening, if there's any dropped packets. So there's a lot of capabilities right in the HiveMQ cloud, including what clients are currently connected. Right now I'm the only client connected, and as I said, it's HiveRio, which was my client, which was my device ID. And there I can see all this information about that client that's being reported by the device because I'm using Sparkplug B. So there you go. That's the live demo from Temecula, California, all the way through Germany and back. I'm going to now pass it back over to the good folks at HiveMQ. And I'll go ahead and leave this screen up. I'll go ahead and change my screen over and give you guys an opportunity to see and go to here. But clearly, everybody's having a lot of fun with that, which is terrific. So there you go. And pass it back over to you, Dominic.
Yeah, thank you so much, Benson. This is really fun, and I actually also used the opportunity to use the dashboard. It's really great, and always great to see how beautifully this works. So for the folks wondering, so there has been a lot of questions already in the chat that have been answered. And we will now also open the floor to questions. So please make sure to ask the questions now. We have some minutes left. And yeah, we are more than happy to answer. So so before we go into the details and some deep dive questions, so what are the resources or next steps to take? So different. So for the MQTT part, on the one side, of course, if you want to contact HiveMQ, you can do this. Here's the email address. Also, if you want to play around, it's easy to get started with the MQTT broker. Just download it. We have a white paper for actual manufacturing released, which might be very interesting. So we have actually a Sparkplug a white paper also coming up. So make sure to monitor. And we have, so I really quickly only talked about Sparkplug. We didn't talk about all the nitty-gritties because of the time. And we have a blog post series, which we're currently doing, which is called Sparkplug Essentials, which also, if you're new to MQTT, gives you a link to the MQTT Essentials, which is one of the best ways to get started with MQTT. You can find it here or these links. And I think, Benson, you also have some great resources here lined up.
We do. As I described earlier, there's a lot of different ways to contact Opto 22, including these links up here. We've also created a page on our website. It's called the Rio Explorer, and it gives you an opportunity to go in and configure or show all the different ways you can configure a Rio for any given sensor. So it's kind of fun to play around with that. You can get to it right from our homepage. It's called Rio Explorer, or from this link. We have all the tech sheets, all the specs. There's another webinar about Rio on there. But one thing that I did want to make sure that you guys were aware of is an MQTT industrial white paper that was recently developed that really takes a deep dive, as Dominic described, into how to use Sparkplug B in industrial environments, moving sensor data, moving PLC data, all of this up to a broker into infrastructure, and allow it to be, that data to be consumed by any application you can dream of. So check out that white paper as well.
Okay, perfect. I think we can now open the floor to questions.
So Dominic, this is Ian. I can start to read off some of the questions if you'd like. So the first question is another question in context of HiveMQ. What is the typical place to put the Sparkplug IIoT hosts, do you offer an enterprise extension to decrypt Sparkplug payload, or did I misunderstand something?
So usually, so especially so for playing around, this is something there is not yet an official enterprise extension. We have seen folks who use the open source HiveMQ extension system. So as a quick reminder, I think I haven't told you this, HiveMQ itself is open source, and we have a professional commercial edition. But the open source broker also comes with a free-to-use open source extension framework. And we have seen people creating their own Sparkplug extension, decoding and doing things with that. Having that said, in a professional setting, you probably don't want to have the IIoT host residing on the broker. This should really be a separated component. And there are a lot of vendors out there who offer you exactly that. So you shouldn't do this on the broker. So we are at HiveMQ, we are big believers at using the best tool for the job. This is why we love the Opto 22 folks so much, because they really have awesome hardware, and also seen also this the software that they provide is top notch, and also they're great vendors who sell you IIoT hosts. And HiveMQ, we really focus on a mission critical enterprise MQTT broker, which is hardened and secure, so you can use it in an industrial setting. So I think it's really important to separate all these components and use the best tools for the job.
So the next one, where are certificates created? How are they used with the MQTT cloud?
So I think this question is a reference to what we've seen with HiveMQ Cloud. So because the Groov Rio used TLS for connecting to the cloud. Mm-hmm. So HiveMQ Cloud makes it easy to use MQTT. So as soon as you start a HiveMQ Cloud instance and basically have a broker in the cloud, what you do is you get all the information like the certificates and so on. You can get it from HiveMQ Cloud. So this is really easy to get started, and also you can create credentials and everything. So this is purely on the cloud side, and then you can use it and configure this on a Rio. And as you have seen this is really a matter of minutes, basically copy pasting the values from the cloud directly into your Groov Rio.
Yeah, and I have the screen up on the Rio here, which shows that configuration. In this particular case, HiveMQ Cloud, the SSL TLS certificate that's on that server was registered with a certifying authority, one of the majors out there. So that means I didn't even have to grab the certificate and put it in the device. I can simply, ensure that that's the correct certificate through a CA. So that made it really simple to connect securely to the broker.
Okay, the next one is, does HiveMQ provide the ability to limit the access to topics for specific users? I'm trying to understand the security model when using MQTT to control hardware.
Yeah. Oh, this is a very important point from my point of view, because security is key, and especially in these industrial settings. Because you probably don't want to have anyone just connect to your broker and then get out all the data and basically listen to all the data going over the broker. And even worse, send malicious commands to the broker, which then delivers it to the devices. So security is key. Actually, MQTT security is a topic. MQTT is secure by default, but it's important also to have additional measures. So what our customers are doing, we have the enterprise security extension, which allows you on the one side to hook into, let's say, your databases, your LDAP systems, or wherever you have this kind of device information located, or you can basically just configure the different topics and make sure that, let's say, the Groov Rio, in this case, would use a specific username and password, and this username and password is only allowed to subscribe to specific topics and publish specific topics. And this makes it very easy to use Sparkplug and the security model here. which I just described, because you can just configure this as you wish and as you want. And this is something most of our customers use heavily, and it's also a matter of minutes to configure this.
There's a kind of question about a demo period to utilize HiveMQ Cloud Broker for POC cases in South Africa. What I'd suggest you do is contact sales@hivemq.com, and we can kind of try and work something out for you for that.
Ian, I have I see a question here I'd like to make sure everybody is aware of, because it's a terrific question. And the question was about using these types of products over cellular networks. And the reason this is important is twofold. One is, remember, MQTT was invented by Arlen Nemper and Dr. Clark with IBM for satellite and terrestrial type applications. So the notion of payload became critically important. And that's why Sparkplug B takes that another level with its binary encapsulation to make that data packet size very small. And in truth, most of our half of our applications with MQTT are on a cellular network. Second part of that is this notion of connections or state awareness. What happens is the MQTT client, in this case on the Rio, establishes a connection with the broker and persists that connection. That's how we know, that's how we have state awareness. And it's critically important in SCADA applications to know that any devices that are part of the system are online. So this is a small little 2-byte header that's sent at a configurable frequency that lets the broker know it's still online. But it still works very well for cellular applications because that heartbeat is so small. And so while that's persisted and the heartbeat's going, anytime a data change, value change happens, that data is published and sent back. That connection state's also important for receiving those messages back for things like turning on the stack light. So great question. Thanks for asking it.
Yep. No, thank you, Benson. There's a question about the HiveMQ Cloud with Confluent Cloud, where the decrypt payload function will be called. So probably a security related question.
Yeah, so if you want to use, especially if you want to bring Sparkplug to Confluent Cloud, so since Sparkplug uses Google protocol buffers, so Confluent Cloud actually is able to decode, and so you can view it also in Confluent Cloud, because they have now also protocol buffer support and also schema registry. What you usually do is, if you want to utilize Kafka, there are two options basically. You just take the whole MQTT payload as basically raw bytes, and you don't interpret it at all, and just push it to Confluent Cloud, where you have applications consuming it from Kafka. Or what you've also seen people done, they're utilizing our Kafka extension. They're utilizing HiveMQ Cloud here in the Kafka extension, which powers this connection. And we have a concept called transformers, where on the HiveMQ side, you can even use custom code if you just want to, let's say, get some values out of the payload and push it to Kafka and distribute to different topics. So you can do very complex things with that if you want to. I would suggest we can follow up on this, on the details, but you can do very sophisticated things here, or just pump it into Kafka and do something from there.
So we don't have any more questions. If there's another quick question, feel free to add it in. Verena, did you have a point you wanted to make?
No, I just wanted to say that there are no more open questions right now, and this is why I would like to close this session if there are no more open questions. Okay, so a very special thanks to Benson and to the whole Opto 22 team for joining us today, and thanks also to Dominic for speaking today. It was really a pleasure to having you and for this awesome talk. I hope everyone enjoyed this session. Yeah, I hope we will see each other next time. So thank you very much.
Thank you, everyone.
Take care. Bye.
Bye.